All right, here we go. We are going to do section 4.2 now. We just finished 4.1. This is called congruent figures. We've talked about stuff, actually, have we talked about stuff that's congruent? I don't think so. Let me show you one thing. Congruent basically means, all right, you guys ready?
Yes.
Congruent basically means, it doesn't exactly mean it, but it basically means that things that are equal to each other. Okay, in geometry, like if I said angle M is equal to 30 degrees, I'm okay if you just say angles are equal to something. But in geometry books, actually, let's not use M because that's going to get too confusing. Oops. Where are we? There we go. Let's use, I don't know, angle A. All right, so we said angle A is 30 degrees. We talked about this earlier in the book. If you look in the book, I hardly ever do this, but they usually don't say angle A is equal to something. They always put something right in front of it. And you might not even notice anymore because I told you I'm not even going to use that anymore. But what do they put right in front of that angle symbol? An M. Why do they put a little M there? The measure of. That's right. Okay, it's the measure of. And a lot of times they'll do this. They'll put a little equal sign with a little squiggle on the top. That's kind of little. Let's do it a little bit bigger. So an equal sign with a little squiggly on top. That little symbol right there, it means congruent. And in geometry books, even when they say that angle A is equal to 30 degrees or the measure of angle A, a lot of times they'll say they're congruent. Or actually, when it just says the measure of, they probably wouldn't say, now I changed my mind. Okay, they probably wouldn't say congruent. What they would say, if I grab that thing, there it is. They would say equal, but watch this. It's a slight difference, but they would say angle A, let's say, was the same as angle B. Let's say they were both 30 degrees. Okay, you'll see this. You won't see a little measure in front of it, the little M, because when they put the little M, they're okay putting an equal sign. But if I just said angle A was equal to angle B, a lot of geometry books don't do that. They get real picky and they say angle A is congruent to angle B. All right, everybody see that? That's a weird looking congruent. Let's try it again. That looks a little bit better. So angle A is congruent to angle B. It just means that they're the same measurement, okay? It doesn't mean they're the same exact angle because angle A could be over here and angle B could be like over here. But the measurements of the angles would be the same. We would say that these angles are congruent to each other. We're going to talk about other things that are congruent, not just angles, but we're going to talk about congruent figures. In this lesson right here, we're not specifically talking about triangles. We're not specifically talking about triangles, but basically the rest of the chapter, we're going to talk about congruent triangles. Everybody hear me on that? Okay, so right now we're just talking about figures, any sided figure, okay, being congruent to each other. So let's just give you a quick little example of a congruent figure. Let's come over here. Let's make a polygon out of it. Okay, there's a nice little polygon. How many sides is this polygon? 1, 2, 3, 4, 5, 6. So it's a 6-sided polygon. So what do we call that? We've talked about this in the past. It's a hexagon. That's right. So what if I do this? Since I got this nice little computer program, I can copy it and I can paste it. Okay. And so if I copied and pasted, tell me something about this hexagon and this hexagon. They're exactly the same, aren't they? All right. I didn't change the size. I didn't change the shape. All I did was copy and paste. So they're exactly the same. So if these polygons are exactly the same, we don't say that they're equal to each other. In geometry, we say that they are what to each other? They are congruent to each other. So I put an equal sign with a what? Little squiggly thing on the top. Okay? I hope all you people with your heads down are paying attention because you're going to need to know this. And you're going to look at me. Shh, don't talk. You're going to be asking me all kinds of questions. So if that's your choice, if your choice to put your head down and not pay attention to anything I say in here, then that's up to you. Okay. So I'm just giving you fair warning that It's just not going to help you. I'll tell you that much. All right, let's name this one right here. Let's just start with A. A, B, C, D, E, F. Okay? So that would be hexagon, A, B, C, D, E, F. Remember, we talked about this earlier in the year. You could start at any point, doesn't make any difference. You could go in any direction, doesn't make any difference. You just can't skip around. I can't call this A, C, E, F, D, B. You follow me on that? I got to go either. If I start at A, I got to go this way all the way around, or I could start at A and go this way all around. How many you got? 6? W, X. V, W, X, Y, Z. V. Okay. I had to go backwards. Okay. So I wanted 6. What are the last 6 letters? It starts with V, I think. So W, X, Y. Oh, I need one more. U. V. What is it? X, Y. This is supposed to be a Y. Z. There we go. Now, I'm 57 years old, and when I try to figure out what letter's next to another one, I'm still like Q, R, S, T, U, V, W, X, Y, Z. Do you do that? I still do that. All right. So anyway, so let's take a look. If I wanted to write that these figures were congruent to each other, this is how I would write it. I would write, now this is not a triangle, so I'm not going to put a little triangle symbol or anything like that. Okay, it's just a what? It's a hexagon, isn't it? So I'm going to say hexagon. We don't have a symbol. We don't have like a special symbol for hexagon. We just write the word. So I could call this whatever I wanted to call it. Where do you want to start? Do you want to start at A? You don't have to. We could be wild and crazy and start somewhere else. Let's start at C, all right? And so which direction could we go? We could go D and around, or we could go what? B and around. Which way you want to go? Yeah, let's go B. Let's go really wild, all right, and go in the opposite direction. So what would we call it? We'd call it what? C, B, talk to me, A, F, E, and D. That's what I would call that hexagon right there, okay? Now watch very carefully. This is super important. This is going to be really important when we start talking about triangles, and it's really important for this. What I need to do, I need to start at the same place on this one as I did over here. So if I took this up, picked it up, and stuck it right on top of there, which ones would match up with the C? What would match up with the C over here? The X would. Okay? So the X would match up. Do you see it? If I picked it up and put it over here, right on top of it, this angle right here and this angle right here are the same exact angles. Agreed? All right. So what would I call this? I'd call this X. Now, which direction did I go on this one? I went to the left, didn't I? Okay, or counterclockwise. So I went C, B, A. What am I going to do here? X what? W, V, U, Z, and Y. That's really, really important. Because when I ask you to show congruent, most of the time we'll be doing congruent triangles. Okay, we're gonna be doing congruent triangles most of the time. This is just kind of leads you into the triangle thing, right, with the figures. But they have to match up. So if I say they're congruent to each other, the C and the X have to match up. The F, almost, it probably was unfortunate using that. I was going to say the F and the U have to match up. That probably wasn't the best. But anyway, the E and the Z match up. The B and the W, the A and the V. Everybody see that? So those are the ones that have to match up. It would be incorrect if you said that this was X, Y, Z, U, V, W. Or even start somewhere else, like at the V. V, W, X, Y, Z, U, or whatever, okay? They got to match up. Everybody's watching, right? Girls, let's not talk. I'm in the middle of talking. I'm in the middle of teaching. You should not have your own conversations going on. So look at the C and the X. They're in the first spot. They're the ones that match up to each other. Let's go to the third spot just for fun, okay? That's the A and the what? The V. Look at the A, look at the V. Are they the ones that would match up if I took one and sat it right on top of the other one? Yeah, they would be the ones that match up with each other. So do you see that? Just reading this thing right here, I could tell you that the E and the Z, right there, the E and the Z are the ones that match up exactly. Does that make sense? Okay, that's really, really important, especially for what we're going to do in a little bit with triangles. All right. All right. So let's do a circle. So we can even have congruent circles. So let's do that. I tell you what, let me do this. Sorry about that. Let me go back to this. What if I did this and then I did that? Are they congruent to each other? Is this one right here congruent to this? Because if I pick this up and put it right on top, is it going to match up exactly? It's not. What's different about them? The size. This is smaller, isn't it? So I should have said this. In order to be congruent, to have a congruent figure, all the sides, the matching sides, or we call it the corresponding side. You've heard that word before, right? Remember we did alternate interior angles and all that stuff? The corresponding sides have to be equal to each other, and the corresponding angles have to be equal to each other. Okay, what did I have before? I had this before. If I took this, and if I could grab it, and moved it, and stuck it right on top of there, it matches up perfectly, doesn't it? All the sides are exactly the same, all the corresponding sides are exactly the same, and all the corresponding angles are exactly the same, right? So in order to be congruent, all the angles have to be equal, and all the sides have to be equal. Make sense? So, again, let's go back to this. If I did this, well, actually, watch this. If I did this, if I just took this and stretched it out, still 6 sides, right? Are they congruent to each other now? No, it's not, because I changed the lengths of some sides, didn't I? All right, now that side stayed the same as that, but are all the sides the same and all the angles equal? No, because if I picked it up, stuck it right on top, obviously they're not going to be exactly the same thing. Does that make sense? Okay, so now let's go back to this. I've got a triangle, got a circle, thank you. And then if I copy and paste and put it right here, if I could grab it, there we go. I put it right there. Now I copied and pasted. So tell me about these circles. They are what to each other? They're congruent to each other. So they both must have the same what? What's really important about a circle? The radius. That's right. So if I went from here to here, all right, and then I went from, whoops. There we go. Close enough. I'll just even draw it right there. So what must be true in length about these two things right here? So if the radius of this circle is 5, and I said these circles were congruent to each other, what could you say about the radius of this circle? It would have to be 5, right? Because if it was more than 5, then this triangle wouldn't sit perfectly on top of this one. Okay? And they would not be congruent. So in order to be congruent, they have to be exactly the same. One has to sit on top of another one. Let's do one. Let's see. I got some triangles here. Let's take one of these triangles and then put it right here. Let's just make it a little bit bigger so we can see it a little bit better. Oops. Come on. There we go. All right. And what if I copied and pasted this one? But I'm going to do something a little bit different. I'm going to take it and just, come on. There it is. What if I rotate it around like this? Okay, so I got 2 triangles. I copied and pasted, but this one I just rotated it around. Are they congruent to each other? Yes. Well, if I took this and I put it over top of it, it doesn't look like it's going to match up, right? But if I did what? Well, if I rotated it, if I can grab these, there we go. If I rotated it and then moved it over, look at that. It's perfect, isn't it? So just the fact of me rotating it, does that make it not congruent? No, it's still congruent as long as what's true? All the sides are what? All the corresponding sides are equal to each other, and all the corresponding angles are equal to each other. If that's true, then these two figures, in this case a triangle, these two figures will be congruent to each other. Let's do this. I think, do I have a thing that just rotates it, transform. Let's see. No, it's not what I want. Have a thing up here. Maybe it's that one. Yeah, there we go. Watch this. Flip horizontally. See what I just did right there? All right. So I just flipped it. All right. So now this side is over here. Okay. And this side is slanting up. This side's slanting down. Bottom's still the same. Okay. So watch this. This is pretty important. Let's just call it ABC again. Make it easy. And we'll just call this DEF right here. Now, if you wanted to show that these triangles were congruent, have we done, I can't even remember. We haven't done triangles at all, have we? I don't think we've done triangles at all. So there's a little symbol for triangle. Guess what it looks like? Triangle. Of course. Yep. So that's our symbol for triangle. So instead of writing the word triangle like we did with hexagon, we have a little symbol and we'll use that. Just looks like a little, no, we're not going to draw a hexagon, okay? We only draw the triangles for our symbols. Actually, a circle back here, there is actually a symbol. Let me show you this while I'm thinking about it. Let's say that's the center of the circle. We'll talk about circles some other time, but this is the center of the circle. We'll call it point A. We would call this circle A, and this is how you write circle A. You put a circle with a little dot, and then you put A. That means circle A. You with me on that? Okay. So now, over here, what do you think I'm going to call this triangle? I could call it anything. It doesn't matter where you start from. All right, you don't have to start at A. You can start at B, and it doesn't really matter what direction you go because there's only two directions to go. All right, so let's just call it ABC just for fun. All right, so if I call this triangle ABC, now here's where you got to be really careful. If I want to show how these triangles are congruent to each other, the A has to match up with what angle over here? The F, that's right. Because remember we took it and we flipped it? So this angle right here, if we flipped it over. So the A and the F have to equal each other. And then the B and the what? What equals the B over here? I hear little whispers. The E, correct. And then, of course, what else? The C and the what? No, the F is equal to the A, right? The C and the D would equal each other. See how I put one arc for those, then I put 2 for the B and the E, then I put 3 for the C and the D. Now, it really makes a difference on how we write this. I will mark problems wrong, and I did it for the honors class, okay? You're going to have problems where you're going to see something similar to this, and you have to write the congruency statement. That's what we call this thing. We call this the congruency statement. Okay, if you want to write that word down, you can do that. Congruency statement. So if I call this ABC, I have to call the other triangle a particular name. Okay, and it can only be one name. So which one matches up with the A over here? So the F has to go first. Which one matches up with the B over here? The E. So the E has to go second. And of course, what else is left? The D. See, the C and the D match up. That's super important for showing congruency statements. And I'm going to have problems on the test and the quiz where you have to write a congruency statement. On the first triangle, you could have called this anything you wanted to. So let's do another possibility. Instead of calling it ABC, what do I want to call this first triangle over here? Let's call it something else. Give me something. CBA, all right? So let's call it CBA. Now, if I ask you to say the congruency statement to this, you got to use the ones that match up. So watch. If I go CBA, I'm going from the one with 3 to 2 to 1. Everybody see that? Yeah. So over here, what are you going to do? You're going to go from 3 to 2 to 1. So what's this going to be? DEF. Again, the C and the D still match up, just like they did right here. They're just in a different spot. Everybody watching? I got a lot of people heads down, looking all around the place. I'm trying to help you out here. Look, the B and the E are in the same place. See, that has 2 arcs, that has 2 arcs. So the B and the E have to both be in the middle. And then the A is the one with 1 arc, and the F is the one with 1 arc, so the A and the F have to be together. What's one more way that we can name this? Instead of ABC and CBA, what didn't we start with? A B, and then we could call it what? B, C, A. Or we could have called it what? BAC. Yeah. And there's all kinds of different options. Okay, we'll just do 3. Now, if I called this BCA, let me scoot it down so you can see those. Okay, if I called this BCA, watch, I'm going from what? 2 to 3 to 1. What am I going to do over here? I'm going to go from 2 to what? 3 to 1. So what are my letters going to be? EDF. Again, the B and the E have to match up, right? The C and the D right there, they have to match up. And the A and the F have to match up. Everybody got that? That's super important. We're going to use that a lot through the rest of this chapter, right? So if you don't get this, if your head's down and you're sleeping and you're not paying attention, you're not going to get the rest of the chapter. Simple as that. I'm trying to give you some warning. I'm not trying to yell at you. I'm just trying to help you out. All right. So that's super important right there. Let's yeah, I think I'm ready to go to an example. Yeah, I think I am. So I'm going to skip example 1 for right now. Let's go to example 2. All right, so this is in the book. And it says, find. Now it says the measure of, but again, we haven't really been doing that measure of thing, so I'm just going to say find angle X. All right, if. Now here's what they tell you. They don't even give you a picture, all right? Let's make that triangle thing look a little bit better. They don't give you a picture. They just give you a congruency statement, all right? They just tell you what triangles are congruent to each other. And let's write it out. So it's angle UVW is congruent to triangle YXW. YXW. They don't even give you a picture, okay? So if this is true, they tell you something else. They tell you that angle U is equal to 22 degrees. And they say that angle, I'll put that right under here, UWV is equal to 30 degrees. Actually, I'm sorry. I lied about this. They do give you a picture. And it comes from example 1. Sorry about that. Yeah, so let's just draw it, because we will need to draw this. Sorry about that. So there's that. I'm going to copy and paste that and then flip it. I think I can flip it. Which one was it? Was it transform? It was this. Flip horizontally. There we go. So this is taken from example 1. If you look at example 1, kind of looks like a like an attic, like inside. You ever go inside an attic in a house? And let's copy and paste that one, and then we'll flip that around. There we go. All right, and let's put some letters in here. This is U, this is V, this is W, this is X, and Y. All right, here's your picture. So now, what in the world do we do with this picture? Well, let's mark some stuff. It says UVW. Let's find triangle UVW. There's U, there's V, there's W. So UVW is this triangle right here. And it says it's congruent to YXW. There's Y, there's X. Candace, not the time. Not the time. This is YXW. So those two triangles that are shaded in right there, they tell you that they're congruent to each other. Okay? Oh my gosh, lost track of time. All right, we'll finish this tomorrow.